Hi, so we're going to jump in and look at some differential mechanics here. So we're taking advantage in these questions of the fact that if I have my position, I can think about my velocity as the rate of change of my position, and I can think about my acceleration as the rate of change of my velocity. Now, a mathematical way to express this idea is with a derivative. So I can say the velocity is the rate of change of my position, so it's the derivative of my position. I can say my acceleration is the rate of change of velocity with respect to time, so it's the derivative of my velocity with respect to time. So what we're going to do is we're actually going to start with a position here, and we're going to find velocity and acceleration. So to find that velocity, I'm going to take my derivative of my position. Now I'm going to keep the i's and the j's separate. I'm just going to look at each case in turn. So I'm going to differentiate with respect to t, 3t minus 4. So if there's a little hidden 1 here, I do my coefficient times the exponent. So that's 3 times 1 is 3. T to the 1 minus 1 is t to the 0, which is just 1. So that is just preserved as 3i plus. And now let's differentiate this. So 3 times 1 is 3, t to the power of 3 minus 1, which is 2, minus 4 times 1 is minus 4, and then t to the power of 0 is just 1, so I have 3t squared minus 4j. So here is my velocity equation, and I can find acceleration by simply differentiating a second time. So if I look here, there's 3t to the 0 here. You can imagine a t to the 0. So 3 times 0 is just 0. So that's going to be 0i plus, we don't even need to list it if we don't want to. 3 times 2 is 6, 6tj. Okay, so let's have a look at these questions now. The velocity of p when t equals 3, so we're going to evaluate my velocity at 3. So that's going to be 3i plus 3 times 3 squared minus 4j. So that's velocity is 3i plus 3 times 3 squared is 27, minus 4 is 23j, 23j. Let me check that maths. 27 minus 4, yeah, 23j. Okay, and let's quickly have a look at this next one. So we have a position r, and we want the speed when t equals 2. Now the speed is the magnitude of that velocity, so it's like how long is that velocity vector. So let's start off by finding velocities. That's going to be 8 times t I, oops, that was a j, I, plus, and then let's go here, that'll be 24 minus 6t j, and we'll evaluate that at t equals 2. So the velocity when t equals 2 is going to be 8 times 2 is 16i plus, let's have a look at this one, 24 minus 12j. So my velocity at a time of 2 is going to be 16i plus 12j. Now the speed is the magnitude of this velocity vector. So we're saying how long is this velocity vector? What we can do is we can imagine a right angled triangle where this is my velocity and it's got two components, 16 steps along the x, I, and then 12 steps up the y-axis, j. And what we're saying is how long is that velocity vector? So how long is that velocity vector will be the speed here, will be the length of this hypotenuse. So we can go ahead and apply our right angle triangle mathematics and say the length of this hypotenuse, so the speed here, the length of my velocity vector is going to be square root 12 squared plus 16 squared. So my speed equals 12 squared plus 16 squared. Square root 12 squared plus 16 squared is 20 meters per second. Okay, I think we'll leave it there.